Good afternoon. Thanks for joining our webinar today, Controls on Every Campus, Why Wireless is More for Education and Healthcare. My name is Holly English. I'll be your moderator. Before we get started, just a few housekeeping items. Across the bottom of your screen, you should see several buttons that are your dashboard. Hover your cursor over the buttons to see what each does. If you click on the Q&A button, you can type a question at any time. We'll answer as many of those as we can in the time that's left at the end of the presentation. Next is the speaker biography button. Click on this to show the speaker's bios or minimize them from your screen. The certification button is important to notice. It allows you to see your progress toward earning a certificate for one CEU. Stay with us for at least 50 minutes of this webinar and answer all of the polling questions to earn your certificate of completion. And you can print that out yourself at the close of the webinar. Pay special attention to the survey button. We desperately need your input to make these presentations even more useful to you. So please bring up the survey on your screen and answer the questions before you leave us today. And finally, the button with the question mark is your on-screen help. This webinar is being recorded and we'll email a link to you, or you can simply use the same link that you used to log on to this webinar. Okay, enough of that. Let's get started. Our presenters today bring a wealth of experience with them. Tricia Foster leads Education Market Development for Acuity Brands. She joined Acuity Brands in 1999, has earned numerous industry credentials, served as Education Chair for the IES Georgia section for 5 years, and was an integral part in establishing the IES student chapter at Georgia Tech University in Atlanta. Mark Phillips is the Product Market Director for Acuity Controls. He's been a lighting industry professional for over 10 years and has spent much of the last few years educating the lighting community on the challenges and benefits of controlling LEDs. Mark's multidisciplinary background spans engineering, sales, marketing, and operations. Tricia will start us off. Trish?
Great. Thank you so much, Holly. So welcome again, everyone. Thank you so much for joining us today and taking time out of your very busy schedule. We're going to go ahead and kick off this webinar presentation with the first polling question. We know that a lot of you may be viewing the webinar in a space with other people. You may have friends joining you in a conference room. We want to get a good feel for how many people are viewing this webinar. So if you're in a space with other attendees, please take a moment to enter the total number of people that are in the room with you viewing this webinar. Okay, we'll go ahead and just keep moving right along here. Here's our confidentiality statement. You guys are used to seeing this on many of our presentations. And then we'll go ahead and jump right into the agenda. So some discussion points for today's presentation are to review wireless technologies and topologies, understand wireless benefits and challenges, and have a discussion about nLight Air. We want to introduce that solution to you and talk about the benefits. So for those of you who are facility managers of healthcare spaces or educational campuses, we know your job is faced with challenges. I think most of you would probably agree with that statement. Just think about it. You have to balance the needs and expectations of many stakeholders. In healthcare settings, there are doctors, patients, and administrators to consider. But then think about school spaces where you have students, parents, teachers, and even principals. You have to be able to meet everyone's needs, and sometimes this is difficult. So on top of this, let's make it a little bit more challenging for you. Think about the spaces you manage. Now, oftentimes it can feel like a small city because there are so many spaces, whether it is classrooms, gymnasiums, and theaters in a school, or even patient rooms, labs, and offices in a healthcare environment. You have to manage your campus so that they have efficient and productive spaces. Now, to add to all of this, let's talk about lighting and controls renovations. Yes, you have to tackle those type of renovations on your campus. Renovations themselves can present challenges such as timing, such as staying on budget, but they're necessary to keep schools smarter and healthcare spaces healthier. Lighting control renovations can seem daunting, but lighting and control renovations do not have to be this way. And that's why we're here today. We want to talk about how retrofitting is simple. we want to talk about how going in and providing these upgrades to your spaces can provide code-compliant solutions. Also, new technologies can now be implemented by changing your control system. And also, we want to talk about how it allows for easy scalability that can be used across your entire building and your entire campus. Basically, we're here to learn why wireless is more. So let's go right into the next polling question before I turn it over to Mark. Do you currently have wired or wireless lighting controls installed in your facility? Please select the correct answer. Okay, and let's see if we can get some results here. So it looks like the majority of everyone at 40% have wired controls, and then at 36% have both. So those are pretty impressive numbers. So I'll go ahead and advance over to the next slide. And Mark, I'll let you go ahead and take it from here.
Thanks, Trish. And thank you again, everybody, for tuning in. So Trish highlighted some reasons why wireless. But I think we've all experienced some challenges and perhaps have some misconceptions or even founded concerns about wireless technology. So I'd like to address some of those concerns. And throughout the presentation, we'll be bringing these up to help you understand what are the questions really to ask yourself, ask your client, ask your customers. What do I need to understand about this system in order to provide a robust and reliable wireless install? So one of the major misconceptions, wireless is confusing and unreliable. Well, that can be true because there aren't any wires. We're typically used to connecting controls to fixtures or interplay devices like occupancy sensors or daylight sensors. But without wires, there's really nothing to see, right? And that's where some of that confusion comes in. But what we're here to tell you is, right, there are things like protocols and topologies that are going to help give you confidence in knowing what the technology is that you're using. Some of those things like batteries not lasting, right? Understand what type of batteries are needed. Are they easily accessible in the equipment? Are they readily available in stores? And what type of profile? Is there any science behind lifetime claims that manufacturers are making? Another thought or misconception, wireless only works in a localized area. Well, that can be true, right, because everything has a limitation, but knowing what the limitations, understanding the frequencies of the equipment are going to help you to understand how reliable, how strong is this signal that I'm sending in between devices. When I turn the lights to go on, are they always going to turn on? Are there things that are going to cause a disruption? Whether it's a wall or a window or multiple walls, how far do I have to send that signal? So know the limitations. Understand on the spec sheet. Look for that information. I think at a bare minimum, what you should find is that there's 300 feet of range. Now, that can be line of sight. That can be through obstruction. But it's an important number to look for to give you somewhat of a reliable estimation that this system is going to work in the area that I need it to. Even though it may say 300 because of walls, because of obstructions, that number may be reduced and may be greatly reduced. But starting at this level is certainly a good starting point. Lastly, it can be easily hacked. I think there's a number of examples out there where systems, whether it's our own personal technology or even lighting systems, have been compromised because of hackers, people trying to get involved into systems that they shouldn't necessarily be allowed into. And that absolutely can happen and does happen with our lighting control equipment. But understand, right, understand what type of security has been implemented to mitigate those things or eliminate those things. And we're going to talk about some things that Acuity Brands has done to really mitigate those concerns. So wireless lighting technology, this is just a fun little image here. This really isn't what we're talking about. We're not talking about being able to provide power to a fixture or a lamp or a light bulb over the air. What we're really talking about are controls, right? How do we communicate to the lighting control systems that we have implemented throughout our spaces, throughout our healthcare spaces, classrooms, education. So Good place to start is why are there so many wireless technologies? If you look at a mobile phone, there are a number of different protocols. You've got 3G and 4G, so cellular connection. This is really good for sending a relatively large amount of data over long distances. Now, this typically requires large antennas throughout our geography that are sending these informations at a given rate, right? 3G, 4G is faster speeds. We've got LTE. We have the capability to send more data faster, but it does tend to consume a lot more power to do that. So long range, a good amount of data. You look at Wi-Fi. Look to use Wi-Fi in your own home environment. Right? There may be some spots within your house where you don't get a good Wi-Fi signal. But Wi-Fi is really good for sending a lot of information or a lot of data in relatively localized areas. So lots of data, local areas, relatively low amounts of power, and that's where the range drawbacks typically come in. If you think about Bluetooth, this really is communication between two devices. So maybe you have a Bluetooth headset, or maybe you're pairing your phone to your car, sharing a little bit of data. Though not very far apart, these devices definitely have a much shorter range than cellular, for instance, but it's not a whole lot of power. So technology we use every day, like this cellular phone, has a number of different wireless technologies embedded into it, and they all serve a different purpose. So they'll serve those same purposes for us when we talk about lighting controls. Now, there are some common industry terms, just some not necessarily listed here, like topology. Like topology is basically how the system is architected, or the shape, or the way a system is formed. Protocol is the language that wireless technology speaks. A protocol that we're familiar with, I think, in our industry, a wired protocol, 0 to 10 volt, right? That is what we're saying between devices and how they communicate. So the ones we have listed here, access point. Go back to this slide. So access point connects wireless devices to wired networks. If you think about your Wi-Fi router at home, right, you've got a wired network coming into it. Maybe you've got a cable modem that's sending high-speed data. That's a wired system that's going to this wireless router. That wireless router is an access point. You have those same devices in lighting control networks. Bridges are going to connect multiple similar networks together, right? Same types of topology, same types of protocol, but being able to extend the capability of that network. A gateway will share communication from one network to another. Maybe you've got Bluetooth devices connected together, and then the gateway is translating that into something else that gets used elsewhere. Maybe it's a wired network, a wireless network, or maybe it's another language altogether. Maybe it connects Bluetooth devices and speaks Wi-Fi. A controller builds on the capability of a gateway. It adds functionality and allows different types of communication to live natively onto that device. So it's adding layers of features beyond simply what a gateway would allow. Looking more deeply into these topologies, again, topology being their architecture, how they actually work together, the how. Bluetooth is point-to-point. And using our examples that we spoke of earlier, perhaps it's a wireless headset working with a cellular phone that has Bluetooth. There is very little overhead, very low power, not a whole lot of information is being shared, but it serves its purpose, right, one to another. So if I were communicating with Trish, right, what I would say is, hey, Trish, in the lighting control scenario, Trish, turn the lights on. And she would turn the lights on. And we would have a dialogue, just her and I within that, in that group. If you look at the classic star or the Wi-Fi topology, right, this is basically that access point where there is one device that is telling many others what to do. So in my example, I would say, hey, Trish, turn the lights on. And she would tell everybody else that's accessing her information to turn the lights on. So this allows us to scale relatively quickly, and provide a fairly reliable backbone to the system. The distributed star, this is basically me now communicating to Trish and communicating to Holly saying turn the lights on, and they in turn are telling their counterparts to turn the lights on. So it allows you to scale much larger than a typical classic star, but also provides some redundancy to assure the commands that are being sent are the commands that are being received. And then lastly here we have the mesh technology, which is often employed by Zigbee, and this is where you have a gateway device that's communicating to all of the devices within its network. So if I were communicating to Trish and to Holly, each one of us would be sharing turn the lights on, turn the lights on, turn the lights on. So there is a lot of redundancy there. This does provide for a robust and reliable signal, but doesn't allow you to scale to the levels that a distributed star or a classic star may. It also has a number of other pieces of hardware that must be included to enable this, this technology. Instead of kind of pulling out some of those pros and cons, so point-to-point, Bluetooth, it is the most simple, easy to implement, lowest cost, but in order to communicate out to very large groups, you need a lot of power. The classic star, large system scale, you have one single access point, so really one point of failure, which may be good, but if that point of failure goes down, the rest of the network can go down. I think we all have experienced that. You know, if we're using our laptops or maybe a tablet at home and the router goes down, no one has access to it, right? So it can cause some issues. With the distributed star, you have basically these more access points that allow for redundancy, or other devices can learn from that access point, contain their own information, and then that communicate to others if one of their signals were to be lost. One drawback here is everything needs to be within one hop, so to speak, from the network, the backbone or the bridge. Mesh, large area without adding many wires, right? We do have the capability to add multiple gateways, multiple devices to increase the scale, but multiple devices are necessary to make that happen. So a lot more overhead is typically needed to scale this system to a level that these others can scale to relatively easily. Now let's look into a little bit more about how this technology actually works. So how does FM work? Friggin' magic. Again, just a little levity here. How it actually works, if we look at our common radio frequency bands, right, this is where we typically play with lighting controls and a number of other devices within a space. If you look at the left-hand side here, AM radio, AM antennas, right, these tend to transmit signals very, very far, potentially hundreds of miles. Right? I can get signals from a very far distance away from the tower, but the fidelity or the quality isn't always as good. But I can send information a very long distance. As that frequency increases, right, we go into our FM bands. And in the FM bands, right, we get a lot more fidelity. The sound is a lot more crisp and cleaner. But in order to send as far as an AM radio, we would require much higher power. So those lower frequencies tend to be able to only transmit a much more localized area or a smaller range than do an AM radio. And as we look going further and further, look at cellular phones, microwaves, some of the more used areas within our space. So for instance, 2.4 gigahertz, that's where the microwave is. That's where a Wi-Fi router can be, right? There are Wi-Fi routers at 2.4, at 5.8, 5.1. And Bluetooth also plays in that 2.4 range. So it can be a crowded area when we start to look at 2.4. So finding a sweet spot for frequency is ideal for a wireless lighting control system. You don't want to be in a very noisy band. So why is frequency important? Well, kind of pulling along the thread of that AM radio. If you think about, if you just walk with me here, walk into your favorite movie theater, maybe it's a multiplex. You buy your ticket, and you're walking past other theaters to get to the movie that you want to see. As you're walking past those other theaters, what do you hear? Well, you tend to hear the explosions or the loud noises, right? You tend to hear lower frequencies, the bass, right? I think perhaps we can all relate to a car driving by late at night and you really hear the bass coming through, coming into your house. Why? Because it's a low frequency. It tends to penetrate objects much more easily than do the high frequencies. You don't typically hear the voices at the movie theater. You don't typically hear the voices of the music coming from that car. So you hear the low frequency. So the lower the frequency, it tends to have a better chance of passing through obstruction when we're using a wireless lighting control system. So lower frequency in an area where you've got much less traffic from other wireless devices, right, as we highlighted Bluetooth and Wi-Fi and microwaves and other technology, all really utilizing the 2.4 gigahertz range. Lower frequencies tend to be much less crowded and often provide a more robust and reliable communication. Now, obstructions aren't the worst thing in the world because what happens is sometimes the signal gets attenuated or reduced, but it can still travel through, whether it's a concrete wall or drywall or windows, right? We have that capability. The lower the frequency, the better. But what we can also do is bounce off obstructions or around obstructions. That's one good thing about wireless technology, that other technologies don't necessarily have that opportunity. You've got to go through them or around them with wires. But with wireless, the technology, the signal, makes its way to its destination. Another challenge or question that we're often presented with is, well, how do I start up the system? Well, there are a number of different methods. Some manufacturers use remote controls. Remote controls allow certain functionality, but they can be lost easily. Laser pointers, right? See, there aren't very many buttons, right, when you compare them to a remote control, so you don't have a lot of flexibility, but when you're pointing at a fixture, at a switch, right, you're going to connect to it, but there isn't a whole lot of programming capability. So smartphone apps are becoming more and more popular, and as we'll talk about, this is what Acuity Brands has implemented with its nLight Air technology. So one thing that happens, and that's not misspelled, shift does happen, right? And this shift that's happening in our industry, in the lighting industry, Acuity Brands, one of, the largest manufacturer of lighting equipment in North America, right? Luminaires are what we do, and controls are what we enable through these luminaires. Now, the shift that's happening, right, is I think experienced in every one of our daily lives and the different things we do, and that shift is towards software and capabilities and features. Well, if we think about what's going on, if we think about what has been implemented, like Steve Jobs had the great idea that there was going to be a device that connected people to things and things to people, and that's the smartphone. Right? In principle, the smartphone it's a cellular phone that allows me to take pictures and do some other things. Now, what it allows me to do is add applications. So a question I like to ask people a lot is, I've got a smartphone. Is it a GPS? And most people say yes. And I say, well, not necessarily. What it does is it provides all the hardware to become a GPS, right? But what we've got to do is download an application, and that app enables us to pull out the information and present it in such a way that it makes it easy for us to navigate, right? So I ask you, when we look at a luminaire, is that a GPS? Well, I think most of us would say no, it's a light fixture. But right, if we can embed the technology, the controls, the wireless capabilities into the luminaire, it is the hardware that now lays the groundwork for indoor positioning, the Internet of Things, wayfinding, asset tracking. because it is the hardware. The hardware is already there, and we can go in and layer in applications. Now, why? Why does this happen? Well, if you think about our built environment, what is the device that exists wherever people are in a space? Well, everywhere that there's a person in a building, you're going to have a light fixture. And everywhere that you have a light fixture, you're going to have power. So now the luminaire, not only can it be a energy efficient, code compliant solution, provide code compliance to the lighting controls as well as the luminaire itself, it can also become this intelligent node that provides the hardware and the connectivity that allows us, through adding in applications, adding in wayfinding, asset tracking, indoor positioning, and a number of the other functions or features that we see happening around us on a daily basis. And that really leads us into nLight Air, a brand new technology from Acuity Brands. You may be familiar with our nLight lighting control system. Basically, what we've done is taken the brain or the state machine of that nLight control system and now provided it wirelessly. So now those same commands that we've been sending for years, over a decade, through Cat5 connection, we now send through the airways. And this really allows us to scale a system. So whether it's wired or wireless, we have a solution with our nLight capabilities. So nLight Air, its promise is to be simple, secure, and scalable. So simple installation utilizing our mobile application called Clarity. Security, right? One thing we set out to do when designing nLight Air was to make it the most robust and reliable architecture, security architecture in the light controls market today. Because as we know, and what we're seeing is the connected nature of devices and systems in a building. And the last thing that we want to happen is allow someone into a sensitive system, maybe a financial portion of our building or sensitive information from our customers or patients or students in a space. We don't want the lighting system to be the weak link in that system. So we've designed a robust and reliable 5-tier architecture that prevents and virtually reduces hacking attempts or efforts from individuals to compromise the system. Now, we all know anybody with enough time and enough knowledge can get into just about any system, and I think we've seen that, given our latest election cycle, right, with emails and whatnot. But in terms of wireless lighting control and security implemented in today's market, we have the most robust architecture available. And when you start to think about scalable, whether it is a single fixture, a room, a floor, a building, or even a campus, nLight and nLight Air are designed to allow you to scale and have communication across multiple devices that share the same information, that share the same protocol, eliminating the need for different devices to communicate, whether it is a translator device or some other interface, right? Eliminating those things, making it easier to implement this type of technology, all while providing the hardware, the capability that allow you to layer in software or applications to enable the Internet of Things, wayfinding, asset tracking, because the hardware is already installed in the luminaire. If you look at what the system becomes, for years, Acuity Brands has been a manufacturer that can provide you all of the technology you need for a campus, whether it's site lighting, parking deck lighting, office lighting, emergency, having that capability through different systems that we can connect to work together. But now, with nLight Air and nLight, right, we can now communicate the same information regardless of the space, regardless of the application. So it really allows you to scale the system. And the nice thing about it is the system starts up the same way. The communication is the same way. It's really one person to start up the system. It's only one knowledge base. It's one number to call to determine what's going on in the space if there's troubleshooting required, right? There really is only one language to understand, and that is nLight. And it's now whether we send it through a Cat5 connection or through the airways. And this is really what's so exciting about this technology is the size to which it can scale, and all while using a singular protocol. So what is the system made of? So nLight Air is a scalable wireless platform, and it's deployed through luminaires, fixtures from Acuity Brands. Here we have pictured the BLT. We also have the BLT-R, which is a retrofit kit, which makes it very easy to retrofit a space and get it up to code, right? Because we're embedding the wireless control system right into each one of these luminaires. And how we do that is through the smart sensor. So this is what we call the RES7. If you're familiar with our nomenclature and nLight, all of nLight devices have an N in front of them, so the NES7. But the wireless devices have the R. So what you'll see from Acuity Brands over the next few months is rolling out of these devices to have both wired as well as wireless counterparts to be utilized regardless of the space. And our communication is not that wireless is better than wired. It really is wireless enables a feature set, as does wired. And it's really up to you, based on your application and your project, as to which solution you want to go with. And we will have the capability to connect both wired and wireless technologies together. We have a number of other fixtures available. We've got a suspended linear and the Peerless Bruno. We've got the Mark Whisper, a more spec-grade troffer, and the WL, which is a hallway and stairwell fixture, along with the VTL coming by the end of February. The other piece to the puzzle here is the wireless battery-powered wall switches, and we have a number of those available. Simple on-off for on-off with dimming, two-pole on-off and two-pole on-off with dimming. And then Clarity, which is our mobile application. Clarity allows you to pair devices just as you've had before, right, with utilizing Bluetooth technology, pairing a phone to your car or your phone to a headset. You're doing those same functions with the Bluetooth technology that's embedded into each one of these products. So how that actually functions is that sensor, which is actually both a daylight sensor as well as an occupancy sensor. This allows for the combination of a Bluetooth radio as well as a 900 megahertz radio combined all within that sensor. So all the smarts are right in there. And through the mobile app, you can pair that to other luminaires, to the wall switch, and set your system up very simply. So a polling question. We're going to speak a little bit more about nLight Air here, but if you're interested in learning more about BLTR and nLight Air, let us know and we'll reach out to you with some more information. A quick yes or no thanks. Thank you for doing that. So you might be thinking to yourself, oh, there's a sensor in each one of these fixtures. Well, there's a reason for that. Simplicity, right? For installation purposes, you don't have to worry about where you're actually placing the daylight sensor or the occupancy sensor. Are there going to be obstructions? Are there going to be false trips, right? There's a sensor in each one of these luminaires that makes it really easy to install. So all you're doing is installing hot, neutral, and ground, or connecting hot, neutral, and ground, placing the fixture in the ceiling, and the rest of the work is all done from the app. Very simple, very straightforward. So smart building ready, right? The sensor in each fixture allows for high density of intelligence. If we want to add in wayfinding or asset tracking, maybe it's tracking expensive equipment through a healthcare environment. Maybe it's a crash cart or a patient bed. We can attach a Bluetooth tag to one of those devices, and then we can track it throughout our space. Why? Because there's a light fixture everywhere that there a person is, and there's power everywhere that that light fixture is. So now we can deploy these solutions, these smart technologies, truly a smart building based on the infrastructure that's already in place with the lighting system. And then regionally, there are many rebates offered if there is a sensor, a networkable sensor, implemented into a luminaire. So depending upon if you're in the Northeast or in the South or out West, you may be able to utilize or rely on these rebates to pay for a good portion of this equipment. And that will all depend on your local utility. So some of the science behind our claims of 10-year battery life. So we utilize a wireless battery-powered wall switch, as I mentioned. Batteries come included and installed, make for very easy installation. And off-the-shelf, 3 AAA lithium-ion batteries. The profile of lithium-ion is basically that the system works, and then the batteries die. It's not a slowly failing of the battery. So you're going to get reliable performance for those 10 years. And the science or the testing that we've done behind that is basically about 48 switch actuations every day will get you 10 years of battery life. That's certainly a lot of button presses. And if you've got a sensor in each one of these fixtures, the likelihood of button presses of 48 times a day is not likely. So the 10-year battery life is reliable. What we will have coming in the very near future are a full range of scene switches. So allowing you to not only turn the lights on or off and dim them, but to set a scene, to set up multiple zones within a space and have a button change the environment, the look, the feel of the space, all done wirelessly. Clarity, the mobile application, a major feature behind Clarity is that every time a job is started up or installed, all that information, the settings, the devices, the spaces, it's all saved into the cloud. So we have record of what's been set up, what's been commissioned properly, what are the settings for the occupancy, daylight sensors, and we can reference those to assure that, one, we're up to code, and two, that we can go back if there's any need to troubleshoot. We can actually see what the initial settings were, what the most recent changes have done to the system. But in its simplest form, Clarity, again, pairs devices. So identifying fixtures, what you'll do is the app via Bluetooth will select devices and you'll identify a fixture, meaning it will flash. And then you place it on the grid. And this is what's really nice about the system is you get this visual feedback to see, oh, this is where I'm placing this fixture. This is what the space looks like. This is the layout. So you have that information. You understand without wires how the space is in essence wired. And then what you would do is once all the devices are placed in the grid, you'll create your zones. So if you were in a classroom, let's say, and you wanted all the fixtures in front of the chalkboard or whiteboard to work off one switch and the rest of the fixtures in the space to work off another. Right? You can do that right from the app. You create 2 different zones that can work off 2 different switches or one of our 2-pole switches. And then the last thing you'll do is set the behaviors or set the occupancy and daylight sensor settings right from the app itself. You save the characteristics, and then you're on to the next installation. So how does it offer that versatility? Well, we touched on it a number of times. We incorporate into our sensors 2 radios, a Bluetooth radio that is used today for commissioning or startup pairing devices like you do with your car and your phone, or a Bluetooth headset and your phone. And we utilize those Bluetooth beacons, right, for indoor positioning or wayfinding or asset tracking. And then the 900 megahertz radio, again, a lower frequency, a very quiet frequency band, is utilized for communicating the lighting control commands. So you see here, why did we select that 900 megahertz frequency? One, it is a lower frequency and tends to pass through obstruction much more easily than do the higher frequencies, but it's also a quiet band where years ago we had walkie-talkies, garage door openers, other devices all operating at that 900 megahertz. And there are very few devices in 2.4 gigahertz. Well, nowadays, if you look at that, that's kind of flip-flopped, where 900 megahertz is actually very quiet, and 2.4 is full of Bluetooth and Wi-Fi, microwaves, refrigerators, all of these devices working on 2.4 gigahertz. You might be asking yourself, well, there's been such a move to 2.4, why not this? Well, a lot of these devices are requiring very high fidelity. We're really sending lighting control commands and positioning information. That all can be done on 900 megahertz reliably. So we're not sharing video, we're not sharing high amounts of data, but we are sharing a lot of data over very long ranges, right? Our system is designed such that line of sight for our technology is 1,000 feet, and through obstruction, it's about 600 to 800 feet. So it's significant in terms of its range, and that's really what enables us to scale to the level that we do without the need for interfaces or other devices or repeaters to communicate the information that we're sending out. And how's that accomplished? So the architecture that we employ is the distributed star, which basically functions as there is a device that stands up within a group and says, hey, I'm the loudest one here. Everybody listen to me. I'm going to tell you what to do. So when a button is pressed, a wall switch button, an occupancy sensor sends a signal, it's going to send that back to this group monitor, and that's going to communicate that information out to all the other devices in our group. Now, what's nice about that is if that group monitor were to fail, the next loudest device in the group stands up and says, hey, everybody listen to me, I'm going to tell you what to do. So it really combines the benefit, the speed and scale of a star with the reliability of a mesh network. If you look at recently, we start to talk about security. Here's an article in the New York Times, why light bulbs may be the next hacker target. Popular mechanics, watch this building, smart lights get hacked by a drone. I think these were from November time frame. And then in October, there was actually an article, and maybe many of you experienced it, on the coasts of the country, and I think in the Chicago area. What hackers were doing is they were sending large amounts of data out to devices that didn't have security, right? And these connected devices, and what was happening is people's internets were being bogged down, and they were, in effect, rendered useless. So these things are occurring on a daily basis, and what we're hearing more and more about are these, micro hacks or micro ransoms where you've got a connected thermostat and it doesn't necessarily have security built into it. People are basically taking control over that thermostat, and let's say it's the middle of winter in Chicago, and turning on your AC and cranking it down. And then you get a little text saying, well, PayPal me $25 and I'll give you control back of your thermostat. Right? These are happening on a regular basis. Security is very much at the central point of deploying an Internet of Things architecture in connected environments. We actually published an article in Architectural Lighting called The Real Barrier to Delivering Internet of Things Services and Lighting Controls. And this all focuses on security. Again, that very much is top of mind when installing a system, a connected system. So a 5-tier security architecture. If you look at the basic architecture available, encryption, this is like Trish and I, we share an inside joke. I say something different than what I mean. That's basically what encryption is. If someone is able to understand what that inside joke is, it's no longer an inside joke. More people can understand now what we're saying. This is really the level at which we start, and most other systems in the industry stop. We go 4 layers above and beyond that. So mutual entity authentication. This is where I recognize Trish and she recognizes me. And my switch recognizes it's an nLight air switch, and it knows it can talk to an nLight air sensor. Right? We have that authentication. They recognize one another. Authentication comes from a device, so the authenticity. So when I tell Trish that inside joke, she laughs at it. I know that she got it. My devices communicate back saying, I received the message that you sent. Message confidentiality, devices communicate, again, using encryption. This is like us telling that inside joke, but no one actually being able to hear the inside joke, or no one actually being able to see what our devices are sending between one another. And then limited anonymity, being able to communicate that inside joke or communicate our lighting control command without disclosing that it was Trish or I sending that inside joke or my devices, what they are. Is it a wall switch? Is it a sensor that is undetectable? So in a nutshell, nLight Air, simple installation and startup, secure, the most secure wireless lighting control network on the market, and scalable. So a platform that can be built upon for a single room, a group of rooms, a floor, a building, an entire campus, all while providing you the hardware to add in future capabilities or applications like Internet of Things can deliver us through indoor positioning, wayfinding, or asset tracking. So, would you like to continue the conversation with one of our product experts? If you'd like, we can have someone reach out to you and provide more information and discuss any projects that you might have. Don't feel obligated to do that, but we'd be happy to talk about this solution in more detail and help you figure out where it makes sense on some of your upcoming projects.
Great, thank you, Mark. As people are responding to that polling question, we did have a couple of questions submitted during the presentation. So if we could just take a couple of minutes, I'll be happy to read those out to you and let you respond to these. The first one, this individual is interested in transition from interior to exterior lighting. Are there different modules in the nLight Air system for interior versus exterior? Are the devices for the exterior lights exterior rated? And last part of the question, are there additional resources on the Acuity website to gather more information between the transition from interior to exterior lighting nLight Air controls? So that was multiple questions in one question.
Yeah, no, that's a great question, and that is the beauty of what nLight Air provides. That wireless architecture, 900 megahertz, allows us to basically transcend those spaces from interior to exterior all on one network. Now, what Acuity Brands has today, we've got our roam technology that is typically deployed in parking lots. We've got X-Point Wireless in parking garages. So we have wireless networks for those two applications. nLight Air capability for those two systems, parking garage as well as parking lot site lighting, is coming in the very near future. So there's some information on that on our website. If you go to acuitybrands.com/nLight Air, you can find your way to more resources about the products, the parts and pieces. But the capability to expand through our outdoor systems or outdoor spaces is absolutely on our near horizon.
Okay, great, thank you. And here's another question. Are the wall switches available with wired power as an option?
Today, the wall switches are battery powered only. We do have a wired option coming again in the very near future. nLight Air was a brand new platform we just launched in the last couple of months, and we'll be building it out to basically accommodate many of these needs so that virtually the product that you see today from our wired nLight system, you will have wireless counterparts for each of those devices.
Okay, and we're continuing to get several more questions, so if you don't mind, I'm going to go ahead and take some time to ask you as many of these as we can. For those of you on the phone, I just want to let you know that if we don't get to all of the questions during this session, that we will type up responses to every single question that was submitted, and we will communicate that to you once we have that all together so that you will see responses to everything. So the next question says, when you say environmental sensing, do you mean temperature?
Environmental sensing, we have a solution today from our, there's another company, part of Acuity Brands that we acquired and have been wrapping into the nLight architecture, and that company is called Distech, right? And Distech and nLight have come together in the nLight Eclipse. So we have sensors available that can connect to that controller that can monitor environmental temperature, CO levels. So there are a number of sensors available to measure different types of environmental elements, so to speak.
Okay, thank you. And here's another question. Does the Clarity app have a setting to just simply view what's been programmed into the system for a commissioning agent or a building inspector?
So that is a feature. We have diagnostics, and we just updated the Clarity app just a few days ago. So there's a new version now available. We can view that information through the cloud. What we're working on is being able to actually give that to you in the app itself, or allow you to print it out from the cloud to, if you are a contractor or a facility manager and you wanted to have proof of the way the system is set up, will enable you to do that. Today it's accessed through the cloud on the Acuity side, and the next few months we'll enable that through the app and through a web portal.
Okay, and then we have two questions that relate to commissioning. Someone kind of combined these into one single question here. The first piece of it is, how long does it normally take to commission, say, a patient room or a classroom? And the other piece of it is, can Acuity do a full commissioning on large projects as opposed to using the app?
So the way nLight Air is commissioned today, it's all done via Clarity. As we grow into networking these solutions, we'll have other tools very similar to what we have today for a wired nLight system, like SensorView, a portal that you can go into and do all of the programming that Acuity would typically do. So we will have that capability. But today it's all done through the application. If you'd like Acuity Brands to do that for you, we certainly have the people available to make that happen on larger projects, absolutely. How long does it take to typically commission a space? What we've seen is, in a given day, you could probably do an upwards of about 300 fixtures one person can do in an 8-hour day. So depending upon how big the space is, how many fixtures are in a room, that can vary, but it's about 300 fixtures.
Okay, and Mark, I'm going to go ahead and ask you this one last question, and as I said earlier, for everyone else, we will respond to all the other unanswered questions. This last one says, will nLight Air work with other manufacturers' products?
Yeah, so like our wired nLight system, we have what are basically power packs, and those power packs allow you to connect into other manufacturers' devices. They can receive wireless information from nLight Air and then speak 0 to 10 or speak phase control or be switching on the output. So that is a way to enable other manufacturers to participate in an nLight Air network.
Okay, perfect. Well, thank you for taking the time to answer those few questions there. You guys will all receive an email after the webinar where you will get a PDF copy of the presentation. I know a couple of folks have asked about that in the question and answers. So you will get a PDF copy of the presentation, and as I stated earlier, you will get responses to all the questions. Holly, will they receive the survey at the very end of this?
They can pull the survey up at any time on their screen, and yes, we'd very much appreciate it if you, while you're still engaged here, if you take a few minutes and answer the survey questions. I think there are only 6. And also, when you're done with that, if you're interested in the certificate that shows that you've got 1 continuing education credit hour, please print out your certificate for that.
Okay, very good. Thanks again, everyone, for your participation today.
Thank you very much.